Okay, so the third and final example I'll use for finding the rules is from our yellow textbook here. It's not given in the form of a graph, but we've got basically the same sort of information. We've got a couple of distinct values or points that would be on the graph if we graphed it, and which will allow us to find our unknowns. Our unknowns are the capital A here and the lowercase b that we've got. So based on the information that we have, we know that y equals 6 when t equals 1 and y equals 8 when t equals 2. So if we substitute those values, so we've got 6, well, what's going on here? So we've got 6 equals a e to the b times 1, or so that'll be just a e to the power of b, and that's one equation that we have. Second equation is 8 equals a e to the 2b. Okay, now what can we do to solve this kind of simultaneous equation? Okay, we're familiar with substitution method, we're familiar with elimination method. Normally the elimination method we'd use either by adding or subtracting, but we can also use an elimination method by dividing or multiplying. So if we were to divide, okay, that will allow us actually to cancel our a's here, because a divided by a will give us 1. So what we'll do is I'm going to go with 2 divided by 1. So then we have 8 over 6 equals a e to the 2b over a e to the b. Can you see that? The numerator here is our equation number 2 and our denominator is equation number 1. So we're dividing 8 by 6 and this term by this term. As we can see then, our a's are going to cancel each other out. Okay, we can simplify so that we end up with 4 over 3 equals, now e to the 2b over e to the b. We're dividing, which means we subtract our indices, so that becomes e to the power of b, which means that b will equal log base e, or the natural log, of 4/3. Okay, if you need to rewind and have another look at how I work through that, then do that. Okay, so that's our b value. We can now substitute in to 1. Of course, let's have a look here. We've got e to the b equals 4/3, and we've got e to the b here. So we can actually directly replace our e to the b with 4/3, which allows me actually to talk about something which I'll have a look at in a minute. So, a couple of things. We can go 6 equals a times e to the log 4/3, because our b value is log base e of 4/3. We could have directly replaced our e to the b with 4/3. These are equivalent. So this is an important thing. So just make a note somewhere that e to the power of log base e of some value will be the same as that value itself. Okay, so this here is equal to that. For example, if we had log base 10, or at least it was 10 to the power of log base 10 of x, for example, because our base here and this is the same, that will equal x. And that's what we've got here. We've got e and log base e of 4/3, which means this whole thing is equal to 4/3. All right, so that's just an important, whoa, didn't mean to be quite an angle like that. Okay, so regardless of whatever this base is, so we could apply that to any base, right? So if we had n to the power of log base n of x will equal x. So that's just in more general terms. Okay, you might occasionally come across something like that, which will just allow you to simplify that exponential and logarithmic combination. Okay, so what we've got here then is 6 equals a times 4/3, which means that we can solve for a equals 6 divided by 4/3, or 6 times 3/4, which would be 18/4, which is 9/2. Okay, so we've got our value for A, we've got our value for B, and we can write down our rule, which is y equals 9/2 times e to the bt, so that our b value is log 4/3 times t. So that's our rule in this form. Okay. Remember, we can actually change it because we know that e to the power of log 4/3 is 4/3. We could also write that as y equals 9/2 times 4/3 to the power of t. So both of these actually are equivalent. Okay, but I guess strictly speaking, this here is in this form. Okay, but they're both correct.